Hi, welcome to the Chico Math Practice Lab. And in this video, we're going to talk about the second topics, in the polar coordinates. So in this video, we're going to talk about how to sketch a polar curve here. Okay, so in here for this video, I want to show you two methods can help us, to sketch the polar curve. The first method here, since we are so familiar with the Cartesian coordinates, right? So the first method here we will take a look is, if I can change my polar equation to a very familiar with the Cartesian equation by using the relation between the polar coordinates and the Cartesian coordinates. And then if I can change it to a Cartesian equation, it's something we are very familiar with from the geometries, right? And that will be, so that will be a good way, to find the curves here, what the curves will looks like here, all right? So let's go ahead and get a start and try to take a look at those six polar equations here to see what type of curve is represented here. Okay, so the first thing is here, let's take a look at r squared equal to 5. So now let me try to put the relation between. So we have a x equal to the r cosine theta and the y equal to the r sine theta, right? And this is what we learned from the, from the first lectures here, first videos here. Okay, so now let's see here. Also, we have here, we know that r squared is equal to the x squared plus y squared. And also we know the tangent theta is equal to the y over x, right? So this is those are the very, very simple relation we learned from the video number 1 here, the Cartesian and the polar. Okay, so the first one's here. So r squared equal to 5. I know the r squared is x squared plus y squared equal to 5, right? You say, wow, this is a very familiar equation in the geometry. So this one, I can change it to the square root of the 5 to 5. So what type of the curve is this one? This is a circle, right? With radius, what equal to the square root of the 5, and the center at where 0, 0. We are very familiar with these equations, right? Okay, so then the next ones here is r equal to the 5 cosine theta. What type of the graph is this one? Let's take a look again. So well, so how about let me to multiply the r both sides. So I will say r squared equal to the 5r cosine theta. Well, then I know the r squared is equal to the x squared plus y squared. So what is the r cosine theta? R cosine theta is x, right? So this is 5x here. So I can move everything. So it's x squared minus 5x plus y squared is equal to 0, right? Then I'm doing complete the square. I will say x squared minus 5x plus 5 over 2 to the square plus y squared, because in here you add the 5 over 2, right? So from the complete the square, so I know this one I need to use the 5 over 2 to the square. So after complete the square, so what I have here is x minus 5 over 2 plus y square and equal to the 25 over 4. Well, I'll be darned, what is this one again? This is a what? This is a circle again, right? So this is a circle. What is the radius of these circles here? The radius here is 5 over 2. And where is the centers here? Centers will be what? 5 over 2 and 0. So this is the circle, just shift the center to the, to the 5 over 2s here. All right, so now let's take a look at another one. So this one, say r equal to the 4 secant theta. Well, what is this relation then? So let's take a look here. So now the r equal to the 4 secant theta. Okay, so what I can do, let's say here, I move the secant theta over, right? So r over secant theta equal to 4. And what is the 1 over secant theta? Is cosine theta. So it's r cosine theta equal to 4. Oh, wow. What is that? R cosine theta is x. So is what? Is x equal to what? X equal to 4, right? So it's pretty simple. So I know this one's here is vertical lines, right? So it's like the vertical lines here. All right. So the graph of the polos for this one is vertical, so it's a vertical line. Okay, let's take a look at the theta, pi over 3. Okay, so in fact, in here, pi over 3, so like if you do in the polar coordinates, because the theta is fixed, right? So we know this is, so we'll build something, the line like here. So this is pi over 3, right? Okay, so let's take a look how do I do that? By using the Cartesian. So I know the theta equal to the y over, tangent theta equal to the 1 over x, right? So I will say tangent pi over 3 is equal to the y over x. So what is the tangent pi over 3 is here? It will be the square root of the 3, right? It's equal to the y over x here. Okay, so now you get a y equal to the square root of the 3x. So this is what is a line. This is just like what we suspect in here. Okay, so the last two is a little bit like I said here, r squared equal to the cosine 2 theta. So, what is the, what could it be? And then you say, okay, cosine 2 theta. All right. So I'm going to use the double angles to do that. So the cosine 2 theta, you will say is a cosine square theta minus sine square theta, right? So okay, so this is equal to what? This is equal to 1. So now you can put this is r cosine square theta minus r square sine square theta equal to 1. Okay, so now take a look here because I want to use this relation, right? So it's x cosine. So this can be r cosine theta, the whole thing square, minus r the sine theta, the whole thing square equal to 1. Wow, what is this one? Oh, this one is x squared minus y squared equal to what? Is equal to 1. Does this sound looks familiar from our geometry? Oh yes, what is this one's here? So this one is a hyperbola, right? So this is hyperbola, and center, where is the center? Center at where? Center at the origins, right? Okay. Right, so this is a hyperbola. Okay, so now let's take a look at the last ones here. So the last ones here, this is the r squared sine 2 theta. All right, 2 theta. Well, what can I do? You can say, okay, r squared sine 2 theta. I can use the double angle again. Sine 2 theta will give me 2 sine theta cosine theta equal to 1. That's right. All right, so now I can do I will do 2, right? So I will put a 1 r in here and another r in here. So I will say 2r sine theta, all right, times r cosine theta equal to 1. So what is the sine theta? So this is 2y what? So 2y times x equal to what? Equal to 1. right? And that means y times x equal to 1/2. Wow, what is this graph here from the geometry? We said this is a hyperbola again. Right, so this is a hyperbola again, and also centered at the origins, right? Okay, so this is the first method here. If I can manipulate the polar equation and to change it to some equation we are familiar with in the Cartesian equation format, then we can identify what type of the curve, is generated by the certain polar equations here. All right, okay, so the next method here is, let's take a look here. The next method here, all right, is we know sometimes it's not easy to find the equations in a Cartesian plane, so we are familiar with here. All right, so the r squared equal to the -2r sine theta. For these ones here, you can change to the, you can change it to the Cartesian equation. We did one very similar one. So this is -2r sine theta. And we did one, a very similar one, like the second one here, r equal to 5 cosine theta. So here is the circles, right? So this one is it will be a circle and the center will going to be shifted, right? But now we are going to take a look in a different way. So what is the different ways here? So the different ways here, I'm going to use the graph, all right, of r as a function of the theta in the Cartesian coordinates. So here, take a look. This is similar like the x coordinates. This is y coordinates here. But this is just simply you plot, just simply you plot the, the similar, just like you plot the y equal to the -2 sine x. All right, so that's what we said, r as the theta in the Cartesians. This is in the Cartesians, right? Okay, so because we are very familiar with it, so like a sine theta, so we know this is the pattern of the sine thetas, right? And here is negative, so you flip, and the -2, so here. So this is so be careful, this is the Cartesian, all right? So this is in the Cartesian, right? So you use the Cartesian coordinates to do that. Like I said, you can just treat as y equal to the -2 sine x. So I know the graph is like this. Okay, so now here, how do we use this graph to try to do a polars here? Okay, so without try to change it to the Cartesian equations here. Okay, so first take a look here, right? So here, so I know this point here, this is pi over 2. And then this is the 3 pi over 2 here. Okay, so take a look here, right? So when okay, so in here, okay, so from the, okay, so from the 0 to pi over 2 here. So when the 0, this is zeros, right? And to the pi over 2, let's start to increasing, it's getting big, getting bigger and bigger to the -2s, right? In here, okay, so be very careful here, right? Because this is a negative value, right? Because this is a Cartesian, this is a negative value. So for examples here, the first point here, I start with 0. Then at the pi over 2 here, so let's put this is 1, 2. This is 1, 2. This is, okay. So when the pi, okay, so at the pi over 2 is -2s, right? Pi over 2, that means you swim to here, but it's -2. So what happens here? So it will be this point here, right? And also think about here. So for everything here, right? So like, for example, like pi equal to the like if the angle equal to the pi over 6, right? So pi over 6, then, so for the pi over 6, you're going to have -1, right? So it should have a -1. So pi over 6, remember, so if this is my pi over 6, right? So pi over 6, I'm going to have -1 here. So if this distance is 1, right? So this is distance is 1, and this is pi over 6. And so remember from the first video, then this will be what? This will be switch to the opposite side, right? So this will be switched to the opposite side. So that's why it's going to switch to the -1 here, right? So this one will be -1. This is a +1, right? So from here to here, right? So I know it's going to, the continue change here, all right? Okay, so now let's take a look here from the pi over 2. So, okay, so from the here, I'm going to switch to, let me do a graph here. So here, okay, so in fact, the graph, okay, so I don't know, I can do it good on that. The finished graph is circles here, all right? So finished graph is a circle, and it's the shift circles here. Okay, so let's take a look here. So this one's here, right? All right, so this one's here. So when the when the angle go to the pi over 2, I'm going to switch to where? I'm going to switch to the negative, the pi over 2, right? So I'm going to switch to the -2 here. And then from the pi over 2 to pi, right? So from the pi over 2 to pi, let me give it different colors here. So from the pi over 2 to pi here, right? Pi over 2 to pi, that means if you swim any angles in here, right? And because it's negative, so what are you going to do here? We're going to switch back to where? You're going to switch back to this side here. Correct? So going to switch back to this side. So this green segment is really switched to this one's here. And this red going to get over here. Okay, so now if you take a look, right? So for anything, so anything from the pi to the 3 pi over 2, anything to pi to the 3 pi over 2, the value become positive. So anything from here, so let me try to use a color. So if you swim from here to here, it will be, so it will repeat the pattern again. So it will be the red ones here, right? And then the same ways here from 3 pi over 2 to 2 pi, it will be positive. So that means in here, this one is here, because it's positive, that means you don't need to go backward, right? So for the yellow ones here, you're going to, right? So you're going to have here going to, so it's go like this, and then the blue one is go like, touch the green one. So it will be repeat, right? All right, so that is how do you use the Cartesian equation, because we know how to plot the Cartesian equation. It's pretty easy. And now let's take a look how, that's how that change to the polar. All right, if this one is not very clear, all right, so now let's take a look at the other ones here, all right? So the other ones here, let's take a look this one here, right? So this is 1 minus cosine theta here. Okay, so now still let's try to see here. So this is the pi, all right? So this is the pi. So so when the x start, right? So when the when the theta start, we can plot this graph pretty easy in the, just use y equal to the 1 minus cosine x. So you will be able to see this graph in the Cartesians here, okay? So now let's take a look at how do I use this Cartesian to, to produce the polar here. Okay, so take a look here. When the theta from the 0, so it's a continue going up. When it reach to pi, what they reach to, the reach to 2 here. All right. So now that means, okay, so we start with the small value, like very close to, the very close to 0. Okay, so let's get a middle point, the pi over 2. So for the pi over 2 here, okay, so for the pi over 2, it will be what? The r here is 1, right? So that means, okay, I'm swing. So here, this is 1, 2, this is 1, 2, this is 1, 2, right? So when the pi over 2, I'm going to touch the 1, right? Now I'm continue going up, right? So I'm continue going up. So I'm going to get bigger and bigger, and then come back down here. So when the pi equal to, when the, the theta is equal to pi, because see here, you already swim the whole pi's, right? So it will reach, what here will reach 2 here, right? So this is 2 here. So basically, we'll tell you this curve corresponding to this curve is right. Right, so the, okay, so now let's take a look at the other ones here. Okay, so after, after it reached the pi, then it's continues going down to 0. But it seems, it's all positive, right? So I don't need to flip back and forth. So also when the pi, this one is equal to the 3 pi over 2, and my r is 1 again. So I can do the same things here. So this one here is going down here. All right, so going to go like this, right? So when I reach the 3 pi over 2, then here going to go to the zeros here. All right, so that's why this one's here. So this graph here, this period corresponding to this period here. Okay, so this is kind of like sorry about my, my graphic is not very smooth, but I can be very difficult to. So this is kind of like the heart, right? So this is the famous like the heart here. So you go like this, and so so that's why you put an arrow. You go like this, and so you can see the corresponding the values here. All right. So now let's take a look at the next one. The next one is here. This is 2 times 1 plus cosine theta. Okay, so let's do the same thing. So it's 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now let's take a look at this ones here. The first one, okay, so this is a pi, all right? So let's take a look at the pi over 2, because I need to go swing all the way, right? So the pi over 2 here, what is here? So pi over 2, I know is 2 here, right? Now also here, this is 3 pi over 2. So what is the y value? Is 2 here also. Okay, so now let's take a look here, right? So, okay, so when the, theta equal to 0, I'm starting here. All right, so when theta equal to 0, I got a 4. All right, so I have a 4 here. All right, I have a 4. And then I'm going to go, my distance will continue going down here, right? So when the time when the time I swim to the pi over 2, my distance only going to be what? Be the 2's here, right? So here I'm going to have a graph like that. And then after pi over 2, so remember this right now, this is a pi over 2, right? So after pi over 2, then my angle, you know, my length going to the r, this is the r's, right? My r going to go getting smaller and smaller. And finally, when it reach the pi, is going to hit the, it's going to hit the zeros here, right? So this is the here, we're going to hit the zeros here. So I know this curve corresponding to this red one. Okay, so now in here, the next one is here, you see, after the pi, right? So after the pi, start with very small, then when the time they reach the 3 pi over 2, it's going to be 2 again, right? So it's going to be 2 again. So here, let's see here. So that means start with 0, then it's continue increasing. So here, going to be here, right? Then after 3 pi over 2, right, then it continue grow to where? To grow to 4. So this will be it's the heart go backward, right? So I know this one's here, it will be this green will corresponding to this green here. So as you can see, we are very familiar with the Cartesian graph. So like in here, we can graph it, just treat this is y equal to the 2, the 1 plus cosine x. So you can graph it in the Cartesians, right? So this is, don't forget, this is the Cartesian. And then you transfer the Cartesian, this is the polar, right? So the only thing here is if your r become negative, then that is the one, sometimes it's a little bit confusing here. You're going to have a, you're going to have a flip to the other directions here. All right, so let's take a look at a little bit harder one. So let's take a look at this one. Okay, this one is 1 plus 2 cosine theta. And you can also just graph this one in the Cartesian's plan. You will say this is y equal to the 1 plus 2 cosine x here, all right? Okay, so now in here, the province here, we have, okay, so we have this negative here. So this is 2 pi over 3 here, okay? So now the first thing here, this is 2 pi over 3. So the first, let's see where is pi over 2, because for this polar, when we swing to this axis is pi over 2 here. Okay, so when the pi over 2, so what it will be? It will be 1 here. So it's 1, 2, 3, right? So pi over 2 will be here, right? So pi over 2 here will be 1, right? So this here, this is pi over 2. And this graph will touch the theta 2 pi over 3, r becomes 0 here. Okay, so now let's see here. So this is a pi over 2, right? Okay, so the first thing is here. So when the r equal, okay, so look at this graph here. So this is 1, 2, 3. Okay, and so this is the 1. Okay. So, okay, so this is 1. All right. So let's take a look first. This, okay, this one's here. All the way to 2 pi over 3. So let's try to find 2 pi over 3. So it is somewhere in here, right? So it's like a 30 degrees, so it's 120. So let's draw a dotted line here, right? So this is 2 pi over 3. If you go all the way to this dotted line, it's 2 pi over 3. So that's why I just do a dotted line here. All right. Okay, so now let's take a look at this orange one. So what is it corresponding to? All right. So when the theta equal to 0 is 3, so I'm going to this way. So I swim. So from the 3, I gradually decreasing. Then when I touch the pi over 2, I drop to 1 here, right? So that's what is my graph here, right? So I'm go from this direction. So here, I put the arrows here so you'll be able to see. So when I go to the pi over 2, it drop to here. Now, when the pi over 2 to the 2 pi over 3, that's this lines here. So still is a positive, but the distance, right? This distance is below 1 right now. So I'm going to have a small, okay, so of course, all this is pretty smooth, right? So I have a small values here. Okay, so now here, right? So now let's take a look at the one we dropped here. This one here is from the 2 pi over 3 to pi. It's negative. That means for the old angle, you swim from here, right? So you swim the angle from here because the r is negative. So what you need, like whatever the r's here, you need to flip back to here. Did you see that? Okay, so you need to flip back to there, okay? So now let's see here. How do I flip here? Okay, so this one's here, because this is getting smaller, this is very small, from the very small value and then to the, when the, when theta equal to pi, it will be -1s, right? Okay, so now in here, the -1 pi is supposed to be 1 in here. If you swing to the pi, so I know the -1, so it's going to end in here. So everything between this dot line and the pi going to flip back, right? Because it's negative r. So you will have these curves here. So this little one, green one, is corresponding to this one's here. Okay, now let's take a look at this one. So this one here is from pi to the 4 pi over 3 here. Okay, so now I need to draw another one, the 4 pi over 3. Okay, so it will be something like here, 240 degrees. So you have 60 degrees here, just like before, right? So everything here is negative, right? So everything, if you swim any angles here, is negative. So you're going to flip back to this side here. Okay, so now let's take a look here. So, okay, so by the way, let me write down this one. So this point, the one we flip back here, this is a -1 in the pi. So it's corresponding to this green one. Okay, so now let's grab red ones here, right? So also because you swim in here from the pi to this dot line, everything going to flip back. So this will be what? Will be this point, right? Did you see that? Okay. Now afterward, after 4 pi over 3, so let's say the after, let me find a different color. Gold we already, okay, blue one. All right, so after the 4 pi over 3, then it's all become positive again and to the 2 pi, right? So that means what happens here, the 4 pi over 3, after you're going up, the r start with 0 and then get bigger and bigger. So when the r equal to the 3 pi over 2 will be, the 3 pi over 2 will be 1s, right? So here there will be 1s here. Be careful, this, I make the mark here. That doesn't mean this is a positive 1, this is a negative 1. This is the r, right? Okay, so this is going to be 1. Now after that, it's going to get, so here you're going to get 1s here. This is 3 pi over 2. Right, so the 3 pi over 2, you swim here, this is the distance r, and then you're going to get a bigger and bigger, and then we'll reach the what? We'll reach the 3s here. So this is a kind of like a, this is also is a very famous, the polar, the polar graphs here. All right, so okay, so now let's stop here, and so I hope that this will give you some idea how to graph the polar equation. Of course, sometimes the polar equation can become very complicated here. So the only thing you need to be careful here, if that, you have the, when you graph it, you have the, the R become negative. So when you swing, you need to make sure you swing the backward, right? So, okay, so I guess that's it. And hope this help you to do the, hope this help you to do the polar graph, if you use the Cartesians to hide, to guide you and help you. So you know where for the each points. All right. All right. So nice talk to you. And okay, so let's see what we can do the next. Looking forward to talk to you in our next video. All right. Bye-bye.